All right, welcome back. It is the end of the semester, so let's get ready for your final exam. Okay, so your final exam is going to be focused on data analysis. It'll also have a section where we're looking at distance and velocity graphs. We'll do some forces and we'll do some momentum. You're going to be scored on 3 different proficiency scales. You'll be scored on data analysis, on forces, and on momentum. You've already demonstrated all of your energy understanding in your alternative energy vehicle and in your physics of sports and fire away projects. Actually, physics of sports isn't an energy transfer, but alternative energy vehicle and fire away takes care of your energy transfers, so you're good there. So you'll get 3 scores, 1 for data analysis, 1 for momentum conservation, and 1 for forces. And you'll see those sections as we go through. Cool. So I'll give you the test as a few tables and graphs to take a look at and 4 pages of questions to answer. It'll be really similar to this kind of format where I'll show you a table and then ask you to analyze it. Then I'll give you some information and ask you to figure out what's happening. So let's jump in. So part 1 is analyzing tables. So that's going to be numbers in a table. So we're going to start by looking at this article. So this article is an epidemiology, and it's specifically looking at college athletics injuries. So these are people who play sports for their university. So let's take a look at table number 1. We'll zoom in here. Oops, actually, I'm not sure if this shows on yours, so I'm just going to zoom this way. There we go. So looking at this table, the first thing we're going to do is select 1 row. And the rows are the horizontal pieces running across the screen like that. And let's see if I can annotate here. How about that? So there you go. Yep, I can. Perfect. So I'll annotate that way and we'll kind of show there. So we're going to look at the row for Division 1 in season. So Division 1 is right here. These are the kind of sports that you might see on TV. So the big name schools that give scholarships for sports. And we're going to look at in-season injuries. So first, let's just take a look and see, like, what is this table actually showing? In our case, the table is showing game and practice injury rates for 15 different sports from the National Collegiate Athletic Association, NCAA, for the late 1980s through the early 2000s. So some of the technology will have changed, but largely we're looking at sports, 15 different sports, both genders, looking all the way through. So we're going to look at in-season. So they split it by preseason, in-season, postseason, and then by the 3 divisions. So we're going to look at in-season for D1 athletes, so probably the most serious during the season. All right. So as we look through that row, let's see, boom, I would kind of look right in here and highlight in season. So what do we notice? What I see is the total number of game athlete injuries, game athlete exposures. So that's like 1.9 million exposures. So that would be the number of times that a athlete plays a sport in the season. 31,000 or 32,000 injuries, if I'm rounding. That gives me 16 injuries per 1,000 athlete exposures. And then the 95% confidence interval says, like, okay, that's within 16.06 to 16.41. That's like based off of how much variation could there be in that data. So that is in games. Then in practices, I see 7.3 million exposures, 17,000 injuries for a rate of 2.4 injuries per 1,000. So looking at this row, in season, would it make sense, first comparing the number of exposures, 1.9 million games to 7.3 million practices? That seems to make sense, right? That would be in a given week, if I break it down with like 9 iterations, about 2 games and 7 practices. So a 2-to-7 ratio would be 3.5 practices for every game that you play. That seems about right. So that seems to make sense. And then I noticed that the number of injuries is way bigger in the games, 32,000 versus 17,500. But the one that really stands out to me is this game injury rate per 1,000 exposures. In the season, during games, athletes are getting hurt at 16 times per 1,000 games. And they're getting hurt in practice only 2.5 times per 1,000 games. So does that make sense? I would say yes. I notice that it's about 8 times, maybe 7 times more likely to get hurt in a game than in a practice. And that makes logical sense because I would guess that athletes are trying way harder during games. They're probably going at totally full speed, whereas in practice, you're warming up, you're training, you're practicing a skill, but you're maybe not going at full-on hardcore speed. So that seems to make sense to me, that their injury rate would be much higher during a game, especially in the season. So does it make sense based on human nature? Yes. Based on physics? Yes. And I could justify it based on physics by saying you get hurt with significant force. If you put a lot of force on your body, there's a greater chance of getting hurt, and you're going to get more force, like your mass isn't really going to change between practice and games, but force equals mass times acceleration. During which time are you going to be accelerating more? I'm going to be accelerating a lot more during games, where let's say I'm playing defense and suddenly I need to take off after somebody. That's going to be a quick change of direction, a really quick acceleration. And so that makes sense. I would be doing greater accelerations during the games, leading to more forces and a greater chance of injury. You're probably also like hitting at full speed during the game where you might not be during practice. So based on that row, that totally makes sense and works. Okay, let's do the same thing now, but let's take a look at a column. So for the column, I'm going to take a look at game injury rate per 1,000 exposures and practice injury rate per 1,000 exposures. So that would be this column right here and this column right here. Oops. Sorry, that would be this one right here. Oh, not clicking for me. Yep. There. No. Doesn't want to do it. There you are. Okay. So game injury rate and practice injury rate. Now, as I take a look there, I would see that I have a variety of injury rates. So I'm just going to take a look first at preseason, in-season, and postseason. So in preseason, in a game, I'm seeing 7 injuries per 1,000. Then in season, it's 16. And then postseason, it's 9.5. Division 2 is seeing a slightly lower rate of injuries. And then Division 3 is seeing an even lower rate of injuries, right? 4, 13, 7.9. So would it make sense that Division 1 is going to see a higher rate of injuries during the game? Again, I would say probably yes. Division 1 athletes are going to be the strongest, fastest. That means they're probably going to be going the hardest, and they're going to get the maximum amount of acceleration. They're going to get the maximum amount of force. So the chance of hurting themselves is a little bit higher. If you're a pretty good athlete, but not like a elite level Division 1 athlete, you're Division 2 or Division 3, you're going to hurt yourself. You're still going hard, but you're just not putting out the same amount of force that a Division 1 athlete might have. And so your chance of injury is going to be slightly fractionally lower. I also noticed that the preseason value is the lowest, then in season is the greatest, and then postseason is the most. Why do you think that might be? I think it makes sense. In preseason, you're just kind of like practicing, getting warmed up. You're not really going the hardest. In season, you're going really hard. Now, the one that's confusing to me is that postseason has such a low injury rate. The explanation that I think might make sense here is by the time you get to the postseason, all of the athletes who are going to get injured have already gotten injured. They have made their way through the regular season and they've already torn their quad or broken a bone or whatever. So they are no longer kind of like in the mix to get hurt in the postseason. By the time you get to the postseason, you only have the athletes who are the most healthy. And so those athletes are going to be less likely to get injured. So I think there might be a level of attrition where in the preseason, you're not going the hardest. So you're not getting hurt. In season, you're going pretty hard and getting hurt. And then postseason, you are now have cut out all the athletes who are going to get injured. And so you're left with just the core group of the least injurable athletes. So that kind of makes sense to me as well. All right. Let's also look at the practice rates. So for practice in preseason, we're seeing 7 injuries per 1,000, then 2.4 in season, then 1.6 postseason. So in this case, the rates have inverted. We're now seeing way more injuries preseason, less injuries in season, and then the fewest injuries postseason. And again, I think that makes sense. In the preseason, you're trying to get in shape, you're trying to make the team, so you're working pretty hard. So the chance of getting hurt in practice during the preseason is the most. You're also in the worst shape. You're probably not coming in at your peak athletic conditioning, so your chance of hurting yourself is higher. Then in season, your primary focus is on the games. So in practice, you're still doing a lot of practicing, but it's probably at like half speed. You're saving your maximum acceleration and your maximum force for in the games. And then postseason, your practices are really more like walkthroughs. You don't want to be wasting energy or, at that point, you're already in good shape. You should know how your team is playing. And so it's just going through strategy, doing a bunch of kind of like slower walkthroughs, maybe doing a little bit of running, but not a whole lot of hard hitting or scrimmaging or things that might get you injured. So this, again, makes some logical sense based off of the velocity that people would be going, the force that they would be exerting, the degree of acceleration that they might be experiencing. Okay. So let's scroll down and we'll take a look at table 2. That's figure 1. Let's go all the way down to the table here. So this one's kind of fun. This one is now breaking it down by different sports. And it's looking at a few different types of sports and then different types of injuries. So you'll see up at the top, it has a title. By reading the title, frequency, distribution, and rates of selected injuries, ankle ligament sprains, ACL injuries, and concussions. So ankles, obviously, are your ankle. Anterior cruciate ligament is a ligament in your knee. So that's like a big tear in your knee. And then a concussion, obviously, is a head injury. So we're going to take a look at these, and it's broken down by sports. And this is combined for games and practices. So we're going to look at how many injuries there are, percentage of all injuries, and then injury rate per 1,000 athlete exposures for these various sports. Okay. So same questions as above. Let's take a look at a row, and then we'll take a look at a column. So I'm going to take a look at men's and women's soccer, and then men's and women's lacrosse, because I think those might be interesting. So just taking a look here, actually take a minute, read through the table and see what you notice. Go ahead and pause the video and see what you can see. What stands out to you? All right, welcome back. Now let's come back on and let's take a look And I'm going to focus on ones that really stand out. So for ankles, I'm paying attention mostly to the injury rate per 1,000 athlete exposures, although first I'm going to take a look at a row. So I'm going to focus on soccer because that's one that I'm familiar with, and lacrosse. So lacrosse, I see that ankles are 14 and 17% of the total injuries, and in soccer, they are 17% of total injuries. In terms of injury rate per 1,000 athlete exposures, ankles are getting 0.6 and 0.7, 1.2 and 1.3. So these are all pretty consistent. It looks like soccer is getting slightly more ankle injuries than lacrosse is, which makes sense to me. You're playing with your feet, and so the chance of hurting an ankle would be logical. Let's go down and look at knee injuries. Again, I'm going to look at lacrosse and soccer. Again, men's and women's for ankles didn't seem to make much of a difference. I see very few ACL injuries, many fewer ACL injuries than ankle injuries, right? 0.12, 0.17, 0.09, 0.28. So the one that really stands out there is that women's ACL injuries are at a rate that's like 3 times as much as men's soccer. So it seems like women ACL injuries are at a much higher rate, which is unusual. I wonder if that's something to do with like men have slightly larger legs and so maybe thicker ACLs. Women might be slightly smaller on average and thus have smaller ACLs, and thus it could be easier to tear. It also could just be that women's soccer players go really hard. They're playing at the same pace as men's players. And there could be a lot of change of direction and tearing based on how hard they're playing. And then concussions. Let's focus on concussions because this is a pretty interesting one and people are concerned about concussions right now. So looking at lacrosse and soccer, I see for lacrosse, men's lacrosse and women's lacrosse have a very similar concussion rate, 0.26 and 0.25. And then for soccer, men's soccer, 0.28, and women's soccer is 0.41. So again, women's soccer has a slightly higher injury rate than men's soccer for concussions, whereas lacrosse is very similar. Again, I wonder if this is just that women's soccer, they play really hard. There's a lot of contact in women's soccer. I'm not sure. Okay, let's look at a column then. So for the column, I'm going to look at concussions. And we're just going to kind of pay attention to which numbers really stand out. So I'm going to pay attention primarily to injury rate per 1,000 athlete exposures. And we'll go through and just see what I can find. So it's right here, up and down. So for ankles, baseball is not bad. Basketball is pretty high, 1.3 and 1.15. That stands out. Another one that's high is gymnastics, which makes sense. A lot of ankle for gymnastics. Soccer is really high. And is that wrestling? No, women's volleyball. Huh. And men's spring football. Interesting. So spring football seems higher than men's football. So spring football is like off-season football, not the main season. The main season is in the fall. So I'm curious as to why spring football would have a much higher rate of ankle injuries. But so far, it seems to make sense. They're generally sports that involve quick changes of direction. Again, quick accelerations. If I'm going this way and then I suddenly switch directions and go that way, that's a quick acceleration. And so that's going to provide a great force and could cause some damage. For knee injuries, I bet I'm going to see a similar pattern. Basketball, not as high. This one, women's gymnastics, is pretty high, which makes sense. They are doing lots of spins and then really hard landings. And as we found in our physics of sports videos, when you land, your force on your legs could be 3 or 4 or even 5 times your body weight. So that could be a lot of force, which could do some damage to your knees. Men's spring football, also really high. Okay, and then finally concussion. So this is a really interesting one for me because concussions, we're obviously really concerned about future brain health. Men's football obviously has a reputation for concussion risk, and that was 0.37. injuries per 1,000. So that is higher than things like baseball or basketball. Higher than gymnastics, which makes sense. Gymnastics sees a lot more lower leg injuries than concussions because you're landing hard on your legs. Men's ice hockey has a higher rate than men's football, 0.41 instead of 0.37. And I'm guessing that's because you're on a really hard surface. You're on the ice. And then, whoa, women's ice hockey, 0.91. So that is a real standout. Another high one is women's soccer and men's spring football. So it looks like high concussion risk is associated with hitting something with your head, like women's soccer, where you'd be doing headers. And so the chance of connecting your head on something would be really high. And then ice hockey really stands out. And ice hockey, that makes some sense because you are playing it on ice. That is a really hard surface. And so that's really going to reduce your time of impact. If you have a very, very small time of impact, then you are changing direction really fast. And that's going to increase your force. Remember, mv equals ft, the mass times the velocity equals the force times the time. So if I have a really big change of velocity and a really small time period, that's going to give me a big force. So I would guess you could hurt your head by hitting it with a puck, by hitting another person, or mostly by hitting it on the ground. And in this case, like unlike a field or a gymnastics pad or something where there's some give to it, if you hit your head on the ice, it's not going to give at all. It's really rigid, really stiff, and it's going to be a small time of impact, which leads to a really high concussion rate. Now, it is interesting that women have more than twice the concussion rate that men do for ice hockey. I think there could be two explanations. Number one, women could just be playing really hard. If you're the type of person who gets into women's ice hockey, I think you probably get after it. And so I think they might be going really hard and maybe slightly recklessly, and thus crashing into each other more often, falling over more often. The other piece is that just like societally, we might not start our little girls playing ice hockey as early as we start our sons playing ice hockey. So women playing ice hockey may have less years of skating experience. And so there's a chance that they're falling over more often just because they haven't had as many years of experience. I would guess that the answer is probably that the women are playing really hard, because if you get into women's ice hockey, you're probably pretty fired up to play hard. So I'm not totally sure which of those could be the explanation, or it could be something else, but both totally valid. Okay, so that is data analysis of a table. I will ask you on the final exam to do something like that, to look at a table, to identify a row or a column, to figure out what the pattern is, which column you're looking at. So I would say I am looking at women's ice hockey versus men's ice hockey for concussion rate, injuries per 1,000 exposures. And then try to explain using physics why it makes sense. So in this case, I would say it makes sense because if I decrease the time of impact, I'm increasing the force. So playing on a very hard surface like ice would decrease my time of impact. And since momentum equals impulse, mv equals ft, I would see a great force causing a lot of concussions when my head hits the ice. All right. Come back for part 2, and in part 2, we will do some graph analysis.